All right, so let's get right into it. When we think about AI, we usually picture this super precise machine. But the truth is, it's caught in this incredible tug of war. On one side, you've got scientists trying to lock it down to make it perfectly predictable and reliable. But on the other side, they're letting it run wild, just to see what kind of brilliantly strange ideas it can come up with. Today, we're going to look at both sides of that amazing coin.
Here's something you can try right now. Go to ChatGPT or any other model and ask it the exact same question twice. Now, you'd think you'd get the same answer, right? Especially if you crank all the creativity settings down to 0. You tell it no randomness. But what you get back, well, it's probably not what you'd expect.
And this is exactly what happened when researchers did it. They'd ask the same question and get these subtle but really important differences. One time the answer is Queens, New York, the next it's New York City. Now, if you and I are just chatting with it, who cares, right? But if you're a scientist trying to run a repeatable experiment, oh man, this is a total nightmare.
And that right there, that gets to the absolute heart of how science works. It's all about reproducibility. If you can't get the same result twice from the same starting point, you can't trust anything. These little digital hiccups were basically making it impossible to do reliable research with AI. So a team decided, okay, we have to get to the bottom of this. What is going on?
So yeah, think of this first part as a full-on detective story. We're going on a hunt for a ghost in the machine.
For the longest time, everyone had a prime suspect. All fingers pointed to the way GPUs, graphics processing units, do their math. You see, they're juggling millions of calculations at once, and dealing with all those decimal points, what we call floating point numbers, can get, well, messy. The running theory was that tiny rounding errors were just adding up differently every time.
It really comes down to the order you do things in. So picture this. You take $1 million, add one single penny, and then subtract the $1 million. In all that number crunching, that tiny penny, poof, it could just get rounded off into nothing. But if you subtract the million first and then add the penny, it sticks around. And for years, everyone just assumed that's the kind of chaos that was happening inside the AI.
But then, the plot twist. When the scientists actually put it to the test, they found out the prime suspect had a perfect alibi. The GPU? Totally innocent. If you give a GPU the exact same complex problem over and over and over again, you get the exact same answer every single time. The messy math theory was dead wrong. The real culprit was hiding somewhere else entirely.
Okay, so if it wasn't the hardware, what in the world was it? Well, the investigation led them to something that happens before any of the math even starts, a process called batching.
So when you send a prompt to an AI, you have to remember, you're not the only person doing it. That server is getting hammered with hundreds, maybe thousands of requests at the same time. To keep things running smoothly, it bundles a bunch of those requests together into a batch and processes them all in one big go. It's just smart, efficient computing.
And this is the key. This is where everything gets weird for us, the user. From the server's point of view, everything's perfectly predictable. Give it the same batch of 50 prompts, and you'll get the same 50 answers. But from your perspective, you have no clue what batch your prompt is in. One moment, it might be grouped with 10 other requests. The next, it's grouped with 50. And that difference, that tiny change in context, creates a ripple effect that can completely change the final answer you see.
So fixing this wasn't a simple patch. No, this was like performing open-heart surgery on the AI's core logic. First, they went into a process called RMS norm and basically forced it to use one, and only one, method for its calculations. Second, for the matrix multiplication, they got rid of any shortcuts and made it follow the exact same process every time. And finally, in the attention phase, that's where the AI decides which words are most important. They made sure it treated every word the same way, no matter how big or small the batch was.
And the results were, well, just look at this. It's stunning. With the old system, you run the same prompt 1,000 times and you get 80 different answers. It's basically chaos. But with the new, rebuilt system, 1,000 runs, one single answer. The exact same one, 1,000 times in a row. They'd done it. They'd finally achieved perfect reproducibility.
So case closed, right? We can now force an AI to be perfectly consistent. That's a massive win for science. But here's where our story takes a really interesting turn, because it turns out that not all scientists want a perfectly predictable AI. Some are asking a totally different question. What happens when we lean into the chaos? What happens when we set it free?
And this brings us to the other side of that coin we talked about. Instead of putting the AI in a digital straitjacket, researchers are starting to use it as a creative partner to explore strange new ideas that a human might never even dream of.
Take LIGO, for instance. That's the incredible machine that can actually feel the ripples in space-time when black holes collide. So after decades of humans optimizing the design, scientists just gave an AI a digital sandbox of parts and said, go nuts, make it better. The first things it came up with looked like nonsense, just these weird, lopsided, totally alien designs. But buried in one of them was this flash of genius, an idea to add a 3-kilometer optical ring. It used this super obscure principle of physics that humans had overlooked for 40 years, and it could have made LIGO way more sensitive.
Now that's already a huge leap forward. But hang on, because it gets even wilder. The AI isn't just tweaking our designs anymore. It's starting to invent entirely new experiments, completely from scratch.
A team of physicists gave an AI a challenge: revisit a famous foundational experiment from 1993. It's one that demonstrates how to entangle particles that have never even interacted before. I mean, this is cornerstone stuff for quantum technology.
And the AI, which is named Pythist, came back with a completely new design. And get this, it was simpler, it was more efficient, and it was based on a different physical principle that most experts hadn't even thought about using for this problem. In fact, the design was so out of left field that the scientists who created the AI, their first reaction was that it had to be a mistake. But it wasn't a mistake. The math was solid. And then a team in China actually went and built the AI's experiment. They built the machine from the AI's blueprint. And it worked perfectly. This wasn't just some theory on a computer screen. An AI invented a new piece of quantum technology, and it was proven to work in the real world.
So, let's just step back and think about what this all means. We seem to be watching a fundamental shift in how science gets done. We're moving from AI as a super-fast calculator to AI as a genuine collaborator.
And these are not just isolated incidents. Other AIs are being fed raw, chaotic data from particle colliders and are independently rediscovering the principles of Einstein's relativity. Others are generating new, more accurate formulas to describe dark matter. They are literally finding signals in the noise that our own brains just can't see.
Now, of course, we need to keep things in perspective. As physicist Kyle Kramer puts it, we're still in the very early days of this. It requires a lot of human guidance, a lot of babysitting to get these incredible results. So no, we're not being replaced tomorrow.
But it leaves us with this huge, profound question. We started this whole journey wanting perfect control, and we found it. But in the process, by letting these AIs run free, we found they can discover things we've completely missed. So are we building a true partner in our quest for knowledge, or are we crossing a line, creating something that will one day make discoveries entirely without us?